with our next speaker, we are tackling now three problems that are solved with digital agronomy. And with us is the product manager of Way Beyond. And you see, it's the German efficiency here on stage. So we're coming from one point to the next. But please give him also a round of applause. Kirsopp, thank you.
Thank you. Hi, everyone. Thanks for sticking around. I think in the booklet it says 4 grower problems. I was expecting to only have 10 minutes, so I'm only going to go over 3 today. So I'm Kirsopp. I'm a product manager at Way Beyond. And a little bit about Way Beyond. We work with protected growers to help improve their crop management practices, to improve yield, quality, consistency through digital agronomy. So in the next 10 minutes, I'm going to look at 3 grower problems that we've heard from the growers that we work with that digital agronomy has helped solve. So the first one, we're going to look at heat stress and how a grower has solved their heat stress problems within the greenhouse, how a grower solved their risk of frost damage and their management practices around that, and finally, how a grower managed their lack of visibility of farm performance. So I'll skip past that slide. So first one, heat stress. So this here is Guillermo. He grows berries in greenhouses, strawberries, blueberries, raspberries. And he noted that during the height of the summer, he was getting reduced production than what he was used to. So he went into the greenhouse with a infrared thermometer, and he measured the air temperature, he measured the plant leaf temperature, and he was surprised to find that the plant leaf temperatures in some parts of the greenhouses were reaching as high as 35 degrees Celsius. That's clearly much higher than it should be, but even more concerning, the plant temperature was 5 to 7 degrees higher than what the air temperature was as well, which is a key indicator of heat stress. So what happens when plant temperature goes above air temperature? Well, the plant is experiencing heat stress. It closes its stomata to try and conserve water. But what that does is it means that it loses its ability to cool itself through transpiration. And so it goes in this feedback loop where it transpires less, it's less able to cool itself, and it gets hotter and hotter, leading to heat stress. So Guillermo wanted to understand the extent to which this was happening. He can't go into the greenhouse all the time and take infrared measurements all the time. So he installed climate sensors in key areas of each of his greenhouses. And this is a visualization of what he could see in there. So he was able to identify over time which areas were the most impacted by this heat, which plants were the most impacted by this heat stress. And he was able to see that specific areas of his greenhouse were more impacted in other areas of his greenhouse. Using that, he then went and looked at his crop management practices. So he looked at things like venting practices, his whitewashing practices, and what he found was that the whitewashing practice of applying whitewash at certain times throughout the season, based on historical data, wasn't good enough anymore because of changing climate. So with this data over time and the heat stress data over time and his knowledge of his whitewashing practices, he was able to put together a business case to change the whitewashing practice to use data instead of just the normal timing. With that, obviously whitewashing is a very costly practice, so it took some convincing, but with the data, he was able to change that. And in the next seasons, using this new practice of whitewashing based on light and temperature data and plant temperature data, he saw an increase of 20 to 30% of his production, as well as increased quality and surprisingly increased fruit size as well. So using digital agronomy to understand what was happening and use that to make crop management practices resulted in this increased productivity of his greenhouses. He told us that the information from the solution is so important, it's a no-brainer not to have it. In our next example, we're going to look at how African Blue, which is one of Morocco's largest blueberry growers, managed their risk of frost damage. So for African Blue, they're a large grower. Even in specific areas of the country, there's sort of up to 45-minute drive between each of their farms. So they were relying on weather forecasts to understand whether there was frost risk, but outside forecast and what's actually happening inside of their tunnels can be quite different. So when there was risk of frost, they had to drive out to each farm and actually assess the conditions within the greenhouse to know whether they had to make a decision on whether they started to heat the greenhouse or not. So they wanted a solution where they could remotely understand what the situation inside the greenhouse was without having to get out of bed, drive 45 minutes to a greenhouse, and then I'm not end up doing anything. So again, they installed climate sensors in their greenhouses, and this allowed them to, once there was an indication that there was going to be frost risk with the forecast, allowed them to remotely look at what was actually happening within the greenhouse and make a decision on whether they needed to drive out there and turn on the heaters in the morning or not. So they saved a lot of time, a lot of labor management. With these climate sensors, they were also able to set up alerts so that they no longer had to rely on the weather forecast, but they could get an alert when the conditions inside the greenhouses necessitated an action to be taken. Mr. Aziz, the horticultural manager of African Blue, told us, with real-time alerts via WhatsApp, we can more successfully manage our response to potential frost and disease risk. So not only is it beneficial for farm managers, it's also beneficial for horticultural managers, the production managers as well, to know that the right decisions are being made at the right time. In our third example of a problem that's been solved, we're going to stick with African Blue, and we're going to look at they have an issue with lack of visibility of farm performance across all of their farms. So they're a large grower. They have farms in the north of Morocco. They have farms in the south, about 400 hectares total across the entire area. And so one of the issues that they had was that even though data was being taken in each of their different farms, so they had the climate sensors, which are digitizing the climate data, but they were also taking measurements for irrigation, pest and disease, crop registration. Often that was taken on pen and paper. It was sometimes translated from pen and paper into Excel spreadsheets. But they'd have to wait for that data to come to the head office through reports. Maybe they'd have to call up and ask for that data to find out what's going on. So they wanted a solution where they could quickly, easily, and whenever they needed to, see the data from any farm across the country and be able to compare them. So obviously they had those climate sensors when they were solving their first issue of frost risk. So then they adopted and started to straight to digital record things like irrigation, pest and disease data, crop registration data. What that meant was that in the head office, they could immediately see whatever's going on in each of the farms. If they wanted to understand the difference in climates between one or two farms, or the difference in irrigation between one or two farms, they could quickly see them whenever they needed. They didn't have to re-up the managers at each farm to get that information. One of the production managers told us that they want to compare between farms to see which one is likely to get better quality coming out of the farms that week and route that farm's production to different customers potentially. And with digital agronomy, they could do that without having to run around and wait for those reports to come. Mr. Aziz told us, I can see an overview of the farms myself. Instead of making multiple phone calls to ask for updates, I'm getting faster, more accurate information, and that's saving me time. So I kind of quickly talked through three different problems that I've solved with digital agronomy, but I kind of want to take a step back and talk about digital agronomy as a whole. We've already seen some pretty cool technologies this morning with robotics and AI imaging, but it's important to kind of talk about that digital agronomy is a journey. Trying to adopt everything at once is kind of an impossible feat. And so we've found with our growers that trying to solve one problem at a time is the best way to adopt digital agronomy into day-to-day growing practices. Do you have two greenhouses, for example, that have the same management practices but are producing different amounts, producing different quality? That's a problem that you could start to use digital agronomy to try and solve. And then as we can see with the case with African Blue, once you've solved one problem, it makes it easier to adopt digital agronomy to solve another. Over time, we can increase the amount of digital agronomy we use on a day-to-day basis in our farms. I think that's everything that I had today. If you want to know more about kind of the African Blue problems that we've discussed today, there's a white paper that you can read. We've also got a white paper on yield prediction and why using a holistic view of yield prediction is the best way to understand what's going to be happening in the future. If you want to have a chat to me about some problems that you're having on the farm, I'd love to have a chat on how digital agronomy can help that. I think there's a couple of my colleagues around there. There's Aaron and Selena over there, so if you want to have a chat to them afterwards, please feel free to. And yeah, thanks for having me today.
Lee, thank you for coming and for presenting and for bringing, again, of course, your perspective here on stage. So I look into you. Do you have any questions? I know it's a lot to take in this morning. We do have a coffee break in a second, don't worry. But just, Lee, it is a journey. And to wrap it up again, I mean, you mentioned that the data were siloed. And when we talk about smart farming, farming forward, in this digital agriculture sphere, a lot of the knowledge is also siloed. So how can we break that? What is your take on that to get out of the silos, to really make it accessible for as many people, as many farmers as possible?
Yeah. So if we're talking about if you're talking about a large organization where you've got multiple farms with multiple agronomists and things.
Those are the microphones.
Oh, sorry.
Yeah, so the colleagues have a little bit.
Yeah, thank you. If we're talking about one farm that has multiple farm managers and agronomists, it's really important that each of them talk to each other, and we try and solve a problem that maybe at each farm and talk about how we're using digital agronomy to solve those problems. I think it's always a learning journey as well as an adoption journey. It's a learning journey. You don't adopt a digital agronomy solution and immediately know exactly what to do with your crops. You're always learning. And so I think as businesses as well as growers, we can always teach each other about the best way to change our practices and make better decisions here.
Lee, one thing is, of course, always to get to know the product, but the other thing is really to get to know the person behind it and the personalities behind it. So tell us, what was the biggest learning moment for you on that learning journey working in that sphere? Is there any particular moment where you thought, oh yes, that's it? That's what I love to do it?
Yeah, so I've never worked with greenhouses before this job. And so one of the...
Did you background before that when you say you don't work?
Oh, I actually started in science.
Oh.
Then, used business science, but I'm really about sustainability and helping make more food with the less resources from the environment. So greenhouses obviously were a big interest to me. But there's kind of thing that surprised me when I started with the greenhouse was the scale of production in greenhouses. How much more we can produce the same amount of area that we would outside growing, for example. And so I think if we're talking about farming forward, greenhouses and protected cropping is really a key step in the right direction of producing more with less, which is something that we're really keen on at Radio, of course. If you want to come and talk to us as well, we're here, but we're also right next to Hector, just over there. So please come and chat with us afterwards.
Yes, absolutely. Thank you, Lee Kirsopp. Thank you so much for being here at Fruit together with us.